Hi, my name is Nate, and today we'll look at overhauling the electrical system in our electric piano. I started with the part I was most nervous about, the electric motor. Now this piano doesn't appear to be a high mileage unit, but I knew if the motor had any problems that I wouldn't probably have the skills to fix it. But either way, I had to plug it in and give it a test fire.
Beautiful. Nice.
It is such a relief that this motor is a runner, but I still wanted to take it apart and give it a thorough cleaning.
Ooh, nice. That's cool. Well, I'm no expert, but everything here seems to be in pretty good shape, so I'm going to vacuum this out. It's tempting to use compressed air, but I don't want to push any of this dust further inside. And then I'll wipe everything down with odorless mineral spirits. Yum. From what I understand, this is a centrifugal start motor. To start up, the motor is actually using this switch to get extra power between this contact and this plate inside the motor, and it uses these windings here, these smaller windings, to get the extra power and the correct phase that the motor needs to start up. And once the motor reaches about 3/4 of its rated speed, these weights here fling out and they pull this switch away from this plate. With these starting coils disengaged, the motor can run more smoothly and run cooler. Then, of course, when the motor is powered off, it slows down. These weights retract, allow this plate here to remake contact with this surface so it's ready to start for the next time. I hope that's right. Somebody's going to roast me in the comments. Yummy. This is one of 4 wicks that feeds the oil to the motor. I do want to replace it because, yeah. This is the new material. It's felt. Hopefully I've got enough. I will soak these in oil overnight. Alright, it's all back together and it looks like crap. I'm going to proceed to step 1, which is clean the housing of the motor before disassembly. Yeah, I should have done this first, but I guess I was too excited to tear into it. And as always, I'm cleaning this with odorless mineral spirits, which is a very mild solvent. Much better. Alright, let's see how we did. Fire in the hole. So smooth. Let's do it again. So this is our wiring harness, if you will, for the electric piano. We've got 3 lines here. First is the line in, or the power cord, that brings power into this junction box here. This box houses the accumulator where the bookkeeping is done, and the only off and on switch in this entire thing. This line here runs up to our 1 electric light in the piano, and then this line here runs over to the motor. And that's it. So this is definitely where the bulk of our work in this episode is going to be, is in this accumulator. Looks like there was a little electrical fire here at one point. This is the pneumatic that subtracts a nickel. When I say subtracts, this wheel actually counts the nickels. So the coin chute would come down here, nickel would drop down, it would trip this and allow this wheel to rotate and turn the machine on. I'm going to get these wires out of the way and hopefully we can get a better look at this thing. You know, I think before I take this apart any further, I should do a little CAD drawing to aid me in putting this back together. That's a cardboard aided diagram. This is funny. Before the days of heat shrink, they used tracker bar tubing over their connection points and a bakelite strain relief. Pretty cool. Okay, now we can get a better look at this thing. This part here is our biggest problem and the most important part of the whole thing. This is our switch. This was just dangling in there when I took it apart, but it looks like this was supposed to attach here. This is the rocker that makes our connection. So one of our bigger challenges is going to be to duplicate this part here. The next step is to get these damaged parts out. We'll work to duplicate them and then get it back together. Then we'll take another look at it. Because frankly, I'm not even sure how this works. I mean, it's got to be easier than I'm thinking.
Cool tool. Now I want to take a moment to talk about these because they show up in this episode a lot and they were incredibly handy in this project. Are they pliers? Yes. Are they a wrench? Yes. They're both. I use them as a wrench, but they've got the grip that you would have with pliers as well. You've got these two parallel jaws and this cam action here that allows you to grip these two jaws onto your fastener. And it's adjustable. It also has a narrow profile, which I like for tight spaces. And I found they come in multiple sizes. Now, this is not at all sponsored. I bought these tools, but I really like them, and I find I hardly even reach for these anymore. Take this bolt, for example. Well, you can't, so you're going to need a wrench. Try 12 millimeters. Nope, too small. 13 millimeters. I mean, that'd work if you're a hack job. Okay, let's go across the pond here. 1/2 inch. Nope. It's not even a size. That's where these come in handy. Now, by squeezing the jaws, I've got good contact on the flats, and I'm able to have my hand all the way up to the ends of the handles, so I've got good leverage to turn it. And you can see there is no wiggling between these pliers and that bolt. I mean, sure, you can use an adjustable wrench, but there's always some play between the jaws and that bolt. That's why I call these nut strippers. Cool tool. Okay, I've got this all cleaned up, and now we're on to the next challenge. We need to remanufacture this piece, which pivots on this shaft here, or this screw, and carries this terminal here. This piece here cannot be electrically conductive. I think this is some sort of fiber or bakelite. So I purchased this. It's called Garolite. I think it's like paper and resin. And I'm hoping we can cut it on the table saw to remanufacture this piece. That stuff cut really, really nicely, but man, it stinks like VCRs.
about to drill this hole here, which is a clearance hole for this screw that holds the contact onto this bracket, but I feel like that's just going to be replicating the problem that may have broken this in the first place. Drilling that hole would remove all of this material, and this stuff really isn't that strong, and I don't want this to break again. So I think I'm going to redo this a little bit. I've got this donor screw that I'm going to weld it here, cut off the head, then it'll be a threaded stud.
And this is one of the many bittersweet challenges of reviving these antique player pianos. If you can't buy the parts, you gotta build them. Now, with a new part in place, we can finally see how this accumulator actually works.
Finally, this thing is back together, and now we can see how it works. Currently, with these two contacts separated, the machine is off. When a nickel drops through the slot, it trips this, and those two contacts engage, turning the machine on. When it's time to shut the machine off, that's up to the piano roll. There is a hole in the roll that triggers a valve that closes this pneumatic. This pneumatic moves this escapement wheel, and that wheel opens this back up. When more than one nickel is dropped in the slot, this wheel actually does bookkeeping and counts those nickels. So here's one nickel, turns the machine on. Another nickel is thrown in, and that moves this wheel further away. And when I say it moves the wheel further away, there's a pin on the underside of this wheel that engages with the switch. And as that wheel rotates, that pin moves further away. Every time one song ends, there's a hole in the roll that closes this pneumatic temporarily. And when that pneumatic closes, it moves that pin back closer to the switch. In order for the machine to turn off, this pin must make contact with this lever. When the machine is on, these 2 points are making contact, completing the connection between this post and this post. And of course, when the machine is off, that is open, breaking the circuit.
Now, with all the mechanical work done, we just need to quick replace all the old wiring.
All right, let's see if we can get this wire out. Oh, crap. Holy crap. Dang. Oh, man. Oh boy. Oh my gosh. Nope.
Sometimes you need to fight wire with ire.
Okay, I've got an old bumper jack, an adapter of sorts C-clamped onto the foot, and the wire vice gripped onto the movable portion of the jack.
There's 2 options here. Either A, I'll regret this, or 2, it'll work. Oh!
Yeah, I regret it. Here's one end, and there's the other. Well, it is not budging. Okay. All right, I'm going to try it one last time. All right, fire in the hole. Nope. Well, it just keeps shredding the insulation and breaking them off. Guess I've managed to build the world's dumbest wire stripper, so that's something.
Sometimes you need to fight wire with fire.
Well, that didn't work.
Well, I was hoping with that battery charger I could actually create a controlled short and heat up the wire and maybe loosen it up, but that didn't work.
I was thinking, okay, now I'm screwed. Then it hit me. Maybe they screwed it in? I don't know. Well, yeah, look at that. It's actually going. I'm going to keep working at this, and I'll check back in about 4 hours. Just telling myself that I couldn't do it.
Finally.
I have no idea how they got that in there in the first place. That is just crazy. And for anyone wondering why go through all that work, overall the cloth sheathing looks good, but there is this layer of rubber insulation, and that stuff is not in good shape. And look at all that corrosion on the wire too. Okay, I've got the conduit cleaned out and the junctions cleaned up, so I think we can finally start running some new wires. These are all the supplies I've had to purchase for just this accumulator project. I can see why some people call these things Nickelodeons, because I'm getting nickeled and dimed here. Now, I've never fished wire before, and frankly, I don't even have my license, but I'm hoping I can just put this loop on it here and connect that here. Beautiful. Oh, there's hope in the world. Ha, cool. Nice. So this one I had 2 different lines, so I just twisted the wire around and put some heat shrink on it to bring it to a taper. Well, this little soldering iron wasn't throwing enough BTUs, so I switched to this electric rework station. These are crimp fittings, but I'm going to solder them anyway. Amazingly, I remember to put the heat shrink on before the terminals. All right, everything's back together. Now I'm going to go ahead and get everything back together. Well, we're on to the next stumbling block here. This is our power cord, and I wanted to add some sort of strain relief like this to lock this cord to this box so that if someone swings the piano around by the cord, this doesn't rip out. But this strain relief is just too chunky. It's going to interfere with this conduit here. So I want to try a different kind of strain relief this kind here that is very compact. Now, I've never worked with these before, but I think it'll be a good fit for this tight space. That's if I can figure out how to install it. Let's see. Oh, I think I got it. Oh. There. Nice. Now it looks like an espresso machine. Yeah, that's going to work really well.
Finally, everything is together, and if we did this right, tripping this should turn the light and the motor on, and applying vacuum to this should turn it all off. Here goes nothing. Yes! Uh-oh. A little bit of smoke. That's not good. Well, it seems to have stopped. Let's try turning it off. Once more. I'm not sure what that smoke was. Maybe there was some debris between the contacts there. I don't know, but it seems to have stopped. Thanks for watching.